Okay, today we are in 6-4, writing linear equations. So the equations that we pretty much have already looked at, y equals mx plus b, and maybe this one here. If not, we will today. Okay, this one right here is called slope-intercept form, okay, because we are given the slope m and the y-intercept b. This one right here is useful when you are given certain aspects of a line and need to write your equation from point slope into slope intercept. Okay, so I'll show you what I mean. There's two ways that you could do this, and I'll show you what I mean in both cases when that occasion arises. So for example 1, we are given the slope is 2/3 and the y-intercept is in the coordinate 0, 5. Well, the y-intercept is the y value. Okay, so we can use this information and just fill it right in to y equals mx plus b, because we have the m and we have the b. So y will equal 2/3 goes in for m and -5 goes in for b. That is a very simple case where you don't need to worry about any missing parts. All you do is throw in your m value, throw in your b value, and you are done. Okay? Not quite the same thing with example 2. In example 2, they want the equation of the line that goes through that coordinate. In other words, x is 1, y is 5, when our slope is 3. So let's look at the slope-intercept form. In order to make this a very easy, painless, brainless procedure, we need an m and a b. Well, we have the m, but what we do not have is the b. Remember, the y-intercept exists when x is 0. And in our given coordinate here, x is not 0. So 5 is not the y-intercept. Please do not make that mistake. What we have is an x value, a y value, and an m value. What we do not have is the b value. What we don't have is the y-intercept. So there are two ways in which we could write this equation and get the same equation. Okay, so the first way is to use slope-intercept form, and our unknown is the b value. So what we have to do is solve for b. So we are going to fill in the y value is 5, the m value is 3, the x value is 1, and b is our unknown. So 5 equals 3 plus b, subtract 3 from both sides, and we get that b is equal to 2. Now that you know what b is, you are going to go back to your slope-intercept form and fill it in where it belongs. So y equals, and we know the slope, and we also now know the b value. Okay, so in order to write an equation of a line when you're given a coordinate xy point that's not the y-intercept, along with the slope, you can use y equals mx plus b, and then you have to solve for b. What I like is in the point slope form, it's kind of all inclusive. Okay? Now, what I do need to point out, when it says you have this coordinate that you're going through, that is this value right here and this value right there, okay? And then, of course, your m is given. So if we use the point slope form, we have y minus the y coordinate from the point, and then the slope is given as 3, and then the x coordinate from the point. Now we are going to distribute. And then add 5. I don't know where I got my slope was 2/3. Sorry, guys. That slope is only 3, not 2/3. I have no idea where I got 2/3. Let's just redo here. Rewriting, that's the equation of the line. Sorry, with a slope of 3, I bet all of you were sitting there wondering, when is she going to catch that mistake, or is she even going to? Anyway, the slope is 3. That's the equation of the line. Now, when we add 5 to both sides, that 5 minus 3. So when I said that point slope form is kind of an all-inclusive, we don't need to solve for a missing variable in order to fill it back in and write the equation. All we have to do is fill in our x coordinate from the point, our y coordinate from the point, the proper m value, distribute, and then solve for y. Okay, so let's do, if I have the xy coordinate 3, 2, and a slope of 4, okay, if I use point slope form, y1 comes from the coordinate and x1 comes from the coordinate. So y minus 2 will equal the slope of 4 times x minus 3. So I will distribute on the right and then add 2 to both sides. And that would be my equation, okay? I believe that that is the easier way to write a linear equation. Again, we could solve for b. So in y equals mx plus b, the y value was 2, the m value was 4, the x value is 3, and then we're solving for b. So 2 equals 12 plus b, subtract 12 from both sides, and b equals negative 10. Now, while that is a simple procedure, at least a quarter of every student new to writing linear equations will leave that as their answer, forgetting that you actually did not finish your job once you solve for b. Your job is not done until you go back and write the equation. That's why I have a little bit of an issue with the slope-intercept form and solving for b. Too many students that are new to this think that they're done when they solve for b. Oh, well, I got my b value, I solved the equation, I'm done with my work. That's actually not even the point of what we're doing, okay? So the point slope form over here on the left, again, does not leave any error or any room for error once you plug in all your values. Then you just solve for y. Okay, now example 3. Write the equation of the line passing through this point with a slope of negative 1/2. Okay, so I'm going to use y minus y1 equals m times x minus x1. So the y coordinate is 6. My slope is negative 1/2. And my x1, or my x coordinate, is negative 5. So y minus 6 is equal to negative 1/2 times x plus 5. And I will distribute the negative 1/2, okay, and then add over the 6. Now the problem that arises here is these two things have to be added together, but we need that 6 to have a common denominator of 2. So 6 with a common denominator of 2 is the same thing as 12 over 2, because 12 over 2 is equal to 6. So then the equation would be negative 1/2 x plus 7 over 2. Okay, and again, you could do the exact same thing with y equals mx plus b. Your b value would come out to be 7 over 2, and you would fill in your equation y equals mx plus b and get the exact same thing here. Okay, again, it's not a matter of which one do you use to get the right answer. They will both give you the right answer, of course, as long as you fill in properly and do the math properly. It's whatever method you see as being the easiest for you to execute or the easiest for you to understand. Either way will work. Okay, now we have, very tricky, we're going through the point 1, negative 6, m is equal to 0. Okay, so we will fill in y minus y1 equals m times x minus x1. So the y coordinate is negative 6, the slope is 0, and x1 is 1. So we have y plus 6 on the left. 0 times x is 0x, and 0 times negative 1 is 0. So we get zeros over here. So in other words, y plus 6 is equal to 0. And when we solve that for y is equal to negative 6. Remember, that goes back to our horizontal lines are the ones that have a slope of 0. So y equals negative 6 is through the y coordinate negative 6, right like this. And that is horizontal through the y value of negative 6. And because it is perfectly horizontal, it has a 0 slope, and that is our equation. Okay? Now for example 5. This is where things get real, okay? We have some skills that we have learned to get us this far, and now we need to use all of them, okay? So we're writing the equation of the line that goes through those 2 points, okay? So let's say we want to fill in either one, point slope or slope intercept, doesn't matter. We have 2 coordinates. Okay, so we could pick either the first coordinate for x1, y1 or the second coordinate for x1, y1. What we don't have that we definitely need is the slope. Okay, we do not have the slope, but we do have a formula. y2 minus y1 over x2 minus x1. Okay, so we'll just call that x1, y1. Doesn't matter. x2, y2. You will get the same slope either way as long as you do the math correctly. y2 minus y1 all over x2 minus x1 gives us negative 5 over 3. That's our slope. Okay, our slope is negative 5 over 3. Now, what I'm going to do is I'm going to tell you it doesn't matter which coordinate you use, x1, y1, or x2, y2. And I'm going to use both equations, one over on the left and one over on the right, just so you can see that you end up with the same equation no matter which coordinate point you choose. Okay, so I am using slope-intercept, or point-slope. So y minus 3, I'm using the coordinate on the left, equals m times x minus x1, okay? So y minus 3, negative 5/3 x plus 5/3. Now we're going to add that 3 to both sides. Now, in order for that 3 to be added to 5/3, 3 has to be written with a denominator of 3, so you can add your fractions. So 3 is the same thing as 9 over 3. And then we get finally that y is equal to negative 5/3 x plus 14 over 3. Now, we're going to do the same thing with the other coordinate point. Y minus negative 2, and then our x value is 4. So y plus 2 is equal to negative 5/3 x plus 20 over 3. So far, this is where we are in both of our equations, and so far, they look nothing alike. Well, let's just keep going, okay? So we're going to subtract over the 2. Okay? But in order to do that, that 2 has to be written in terms of a denominator of 3. So 6 over 3 is the same thing as 2. And when we combine our like terms, 20 minus 6 is 14. So as you can see, regardless of which coordinate point you use, you will get the same equation. Just first find the slope, okay? You can see by your equation here that you have everything you need, the y1 and the x1, from either one of your coordinates. What you don't have is the slope value. Find that first, then fill in your either your point slope or your slope-intercept and solve for b, and rewrite your equation. Either way, you will get the exact same equation. Okay? So now what we're going to do, one more example here. One more example. Write the equation of the line that goes through these two coordinate points, okay? So y minus y1, so that's our point slope form. So let's find the slope. Here's x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. Well, notice when we get a 0 in our denominator, that means the slope is undefined. And the only kind of a line that we have where our slope is undefined is an x equals line, which is a perfectly vertical line. So if your slope is undefined, you have an x equals line. So if you notice, look at both the coordinates. both of the coordinates have the exact same x value. So that means our vertical line that would go through those two coordinates is x equals 7. So let's look at that graphically. Okay, the first coordinate, 7, 4, is right there, and then 7, 2 is right there. Obviously, the line is that line right there, which is x equals 1, 2, 3, 4, 5, 6, 7. Okay, so a slope with a 0 in the denominator is undefined, which is an x equals or vertical line through the x coordinate of whichever point, because they are both the same. Okay, very simple. Stay with it. This is the chapter that will be your final exam. Stay with it. We're almost there.